Hello. In this video, we're going to go through learning target 425, which is to calculate the probabilities of inclusive or exclusive events given a table. So what we're going to be looking at is information provided in a table. And typically these are called two-way tables, which is helpful to know, because it gives you information in two ways, in two directions. So there's some information in the columns, and then there's some information in the rows. So two-way table. And in these tables, we can find basic probability, which is what we've been doing, the same formula, the number of desired outcomes divided by the number of total outcomes. Or we can find probability given some additional information. And this is our formula here. So I'm going to focus on this one since this we already know. So this says the probability of A, event A, given B. So this vertical bar means given. And this just means like, what is the probability of something happening given that something else has already happened? So we are assuming one thing is true to be able to find another probability. So for example, we can find the probability of a random student being Titan of the Month given that they're a junior. So we can look at that instead of just looking at like the entire school. And so in order to do that, you find the probability of both A and B. So you look at A and B happening, and then you divide by the probability of B. All right, so it's a little bit more complicated than it looks. Let's look at an example to go through what this is going to be like. So this example says the table presents information about the 810 train cars in service on a railroad. Approximately what percentage of the train cars in service are double-decker cars that have been in service for less than 10 years? So we want to look for this keyword given to see if something has already happened. That's essentially what we're looking for the difference between this and this. I don't see that word given, and it's just simply asking for one type of thing, even though there's two characteristics. And we'll see the difference in a second, but really you want to look for the word given. If it doesn't say that, then we're looking for a specific probability, and to find that we want the desired outcomes over the total outcomes. So our desired outcomes are double-decker cars that have been in service for less than 10 years. That's our desired outcome. And if we look here, we can look at double-decker cars that have been in service for less than 10 years. So you kind of like put these two pieces of information together. We wanted this and this to be true, so this is our answer. And it's a probability, remember, so that's our desired outcome. We put that on top. And then this is going to be out of the total. And sometimes you can, you will be given the total and sometimes you won't. So in this case, our total is over here, 810. So I'm going to put that on bottom. And then we're going to go ahead and calculate this. So 16 divided by 810 gives me this percentage. So again, I like minus percents, so I'm going to be moving that decimal place, so 1.98%. So there's a 1.98% chance that one of the train cars is a double-decker that's been in service for less than 10 years. So not a very high chance at all. So now I want you to pause the video and do the next question. What's the probability that a train car is a double-decker in general? And so notice you have two pieces of information that are both double-deckers, so you have to make sure that you combine them first. So go ahead and find that probability, push play when you're ready to see the answer. All right, so we have two categories of double-decker, less than 10 years and more than 10 years. We add them together to get 98. My total is still 810. And so when I divide those, I get a 12.1% chance of them being a double-decker. So very small. Most of them are single level. All right, so this is just basic probability, like finding the information you want from the table and then dividing by your total. So that is just basic probability. Now let's look at given probability or conditional. This example says the table given shows immigration to the United States from 3 countries in 3 different years. A person is randomly selected. Find the probability that a selected person immigrated in 1990, given that the person is from Ghana. Express your answer as a percent. So this has that keyword, given that the person is from Ghana. Like that is what you should be looking for to see if it's a conditional probability. And so in that case, you're going to have a different total than you would otherwise. So the first thing you want to do is you want to look at the given information. So we are going to say that we're given that the person is from Ghana. So this is the only row that I care about because I know that that is true. They are not from Spain and they are not from Cuba. So we're going to ignore the other two rows. We're just looking at Ghana. From there, you're going to find your probability of whatever you want. So this one says the selected person immigrated in 1990. So that would be this number here. So that's the number we want on top, 4466 on top. And then we want our Ghana total on the bottom. So I'm going to have to calculate this. And that gives us 11,962. So again, like you want to find the combination of those two things, so like 1990 and Ghana, and then the total comes just from the given row. So given that the person's from Ghana, that's our total, not the entire total of the chart like we did up at the top. So this is going to give me my probability. So we have 37.33%. All right, so now you're gonna go ahead and do this U-try. Again, that a person's randomly selected. Given that they immigrated in 1995, what's the probability that they're Cuban? So you only wanna look at your given column. So this is the only one you care about, given that it was in 1995, and then find your probability. So pause it and then go ahead and push play when you're ready. All right, so our 17,937 comes from Cuban and 1995, and then our total comes from the 1995 total. So I had to add up these three numbers to get that. And then when you divide, I get 80%. So an 80.04% chance that if they immigrated in 1995, they are Cuban. And you should be able to tell if these percentages are realistic. If you look here, you can see that the Cuban immigrant population is so much higher than Ghana and Spain in this year that it makes sense that it's an 80% chance for that. So you should be able to tell if your percentages are realistic, and that should help you figure out if you're right or wrong.